Okay, and hello everyone, welcome to my channel. Today I'm teaching you about a very important chapter in your 10th and your inter, which is trigonometry. So today for trigonometry, I have decided three three parts of the chapter, which is identities, elimination of theta, and allied angles. So let's dive into identities first. Okay. So we have three identities, which is sin square theta plus cos square theta is equal to 1, sec square theta minus tan square theta is equal to 1, and cosec square theta minus cos square theta is equal to 1. So these are the three identities which are there in trigonometry, and with this we can actually derive other formulas. Because I did not want to write the formulas because I think it's a bit easy though. You can write it down on your own. So imagine I want to find sin square theta value and I know cos square theta value. So what happened here is I just send the cos square theta that side. If I send it that side, it become minus this value. Let's take this value as a x. Then they become this value. Okay, I'm taking it as k. So 1 minus k. There you go. So we have sin square theta value. 1 minus k. Okay is what this. Then don't go write in your exam spelling k k is that. There, let me just erase that part. Yeah. It's about that, everything's fine, right? Yes. Okay. So let's send the square that side. Imagine you only wanted to find out the sin theta value. So if you send the square that side, it becomes this 1 minus k, which is sin cos square theta root. That's it. There you go. You found the answers. Then obviously you'll have to merge with these, play around with these, and you can derive other formulas with only one identity. So let's take the eraser and then let's erase this, whatever calculations we've done here. Okay. So with that, we are going to our first problem, which is um about this stuff it says. Let me erase this and all. So let's take out a pen and start solve. So the question given here is sin theta plus sin square theta is equal to 1. Then we have to prove that cos square theta plus cos bar 4 theta is equal to 1. Well, now some people, I don't think some people, but many people find, yes, some people find this hard. So, well, let's go step by step. So we know that sin square theta plus cos square theta is equal to 1. Yeah. Now I've directly written then sin theta is equal to cos square theta. Many people who know. People who don't know, let me explain here. So sin square theta plus cos square theta is equal to 1. And for this value to fulfill that this value should be equal to 1, then sin theta value should be cos square theta. Yes or no? Yes only now. So then this sin theta value will become cos square theta. That's it. Yeah. So we are taking that as 1. We are taking that as 1. The first equation. Meaning you don't go apply this value everywhere. As for this question, this value is this, okay? Now, applying 1 in this proof, whatever you have to prove. So cos square theta plus cos bar 4 theta is equal to 1. So cos bar 4 theta can be written as this whole square, right? This whole square is equal to this, isn't it? Because the square a power m whole power n is equal to a power m plus m into n. So cos square theta whole square can be written as cos 2 into 2 cos power 2 into 2 theta, which is cos 4 theta, cos power 4 theta. Easy now. Here, so let's erase that part as square because the amount of part. Okay. Let's take out my pen. Let's continue. So cos square theta plus cos power 4 theta is equal to 1. And then this value, what did we find out? It's cos square theta whole square. So cos square theta is equal to sin theta. And cos square theta whole square, we can substitute the cos square theta value. So it'll become sin theta. So sin theta whole square, which is sin square theta, which is this sin theta plus sin square theta. If you write that down, you'll get this, which is equal to 1. Hence proved. There you go. They're proved. Now let's take out our mouse and go to our second problem. I'll actually, if you want to write this solution and the question down, you can pause the video right here and note it down. Okay, so let's continue. So boy, and that's fine. So let's go with problem number 2. 2 into sin theta plus cos theta whole square minus 2 into sin theta minus cos theta whole square is equal to what? You have to find out the value. Let me take out my pen there. Let's find out the value. So what we know? We know the sin square theta plus cos square theta is equal to 1. Yes or no? Yes, it's right, didn't you see? So then this value minus this value is equal to what? Is basically the question. So I think you guys would be familiar with the binomial theorem. A plus B equals B. So my handwriting is really bad on the computer. So whole square. This is the binomial theorem. I can write it down really fast as wait, I don't think you can see the code properly. Yes, okay. So we can write this down as a plus b whole square can be written as a square plus b square plus 2ab, right? That will become that. So a square plus b square, a square plus b square plus 2ab. There you go. I wrote this value as this. And then a minus b whole square would become a square plus b square minus 2ab. Remember, there's a difference. Okay? So, let me see. So the same thing you do that side and then you pick many yours. Switch to mouse focus. I don't think that's physical. Maybe because it's on 150. You keep it on 100 as GB. Yeah. Definitely. That you must see. Erase all of this which I've written before. For a little bit disturbing. But what you have to do. So, sin square theta plus cos square theta is equal to 1. We have wrote it in the first picture. So it has become 1. And then this value will also become 1. The end. We got that. Okay. And then before we continue, we have to actually note down one value. So 2 sin theta cos theta is equal to sin 2 theta. You have to remember that. 2 sin theta cos theta is equal to sin 2 theta. So what I can explain you as it as is this cos theta will go off. I mean, cos theta will go off means you don't take it again as a different way. I'm just trying to help you out if you forget the value. The cos theta will go off and then the 2 goes to the theta of sec. I don't think you'll understand that. Maybe you might not. If the people who got it, well, they will know. Okay. So, as I told you, 2 sin theta cos theta is equal to sin 2 theta. So, that will become, so that will become 2 sin 2 theta. You're multiplying it right now here. Yeah. So, here the minus will come there and this one goes here. dm. So, now we have to multiply this. Here in multiplying, many people get a mistake. Oh, I'll have to explain you. But then it's actually an easy part. Very less people make mistake. So, but then we have to still go through it. So, 2 into 1 is 2. And 2 into sin 2 theta is 2 sin 2 theta. Correct? Now you will ask me why is there 4 sin 2 theta. I'll explain to that later. So, let's put it as 2 sin 2 theta there. Let's just count it there. And then another one. Now, here is where they can make mistakes. 2 is not multiplied with this whole thing. This value of 2 is actually a negative 2. It's not a positive 2. So what exactly happens right here is this minus 2 will multiply with 1. So if minus 2 multiplies with 1, then the value will become minus 2 because anything multiplied with 1 is the same value. So minus 2. Exactly why I put the minus 2 here. And then this minus 2 into minus 2 minus sine 2 theta, minus into minus is plus, right? So it becomes 2 sine 2 theta. There you go. So 2 sine 2 theta plus 2 sine 2 theta will become 4 sine 2 theta, right? That's what I've written here. And then 2 minus 2 gives you a big fat 0. This is just a bracket, okay? 0. That will become 4 sine 2 theta. There you go. We have completed identities. Now let's continue with elimination. Okay, let me decrease the size. Yes. There you go. I am on elimination of theta. That's yes, so it's over 100 and then yes. So basically elimination is removal of theta. That is elimination. So we remove this theta by applying some identities like let's say like we just learned it just few minutes ago, didn't we? Like about sine square theta plus cos square theta equals 1, and secant square theta plus tan square theta minus tan square theta is equal to 1, and then cosec square theta minus cot square theta is equal to 1. The 3 formulas which we learned before. Yes. And then here I've written, remember, please remember this. Sine 2 theta is equal to 2 sine theta cos theta, and cos square theta minus sine square theta is equal to cos 2 theta. Please remember this. These kind of questions can come. Not exactly these kind of questions, but then while solving, maybe if this kind of value comes, then we can substitute in this value, and that's how a question might come, because it came to me once. Yeah. So let's go ahead with problem number 1. So we have the x value and we have the y value, and you have to find out this value. This should be, sorry, let me erase that. So x is equal to a sin theta and y is equal to b tan theta. We should prove that a square by x square, a square upon x square minus b square upon y square is equal to 1. Now to prove this. So let's do the solution here. So it's given that y is this value and x is this value. So if we square it on both sides, because if we square it on both sides, nothing actually happens. Well, it's the same thing, but then because we're squaring it on both sides, the value also remains the same. So when we square it on both sides, you get x square is equal to a square sine square theta. And then let's send the a square that side. Then we'll get a square by x square. A square upon x square is, x square upon a square is equal to sine square theta. That's what we'll get, right? Okay, now here, but the question is doing, we should prove that a square by x square. So it's actually reciprocal, isn't it? So if we reciprocal the LHS, we'll have to reciprocal the RHS. Let me just do the reciprocal thingy. Yes, that. And then reciprocal that. So that's reciprocal. So when you reciprocal this, you can get a square by x square. And then when you reciprocal some value, you will get 1 by that value, which is sine square 2 theta. 1 by sine square 2 theta. So this is our first equation. That's what we find out first. Next, let's go on. Now y square is equal to b tan theta. Now we are squaring again on both sides. You get y square is equal to b square tan square theta. Y is equal to b square tan square theta. Let's continue. Let me just go a little bit down. Yes. Let me confirm. And then yes. So y square is equal to b square tan square theta. And then when you send it the other way around, you get y square by b square is equal to tan square theta. Not the other way around, you're sending the RHS value to the LHS. That's when it becomes y square by b square is equal to tan square theta. And then this reciprocal is not the same thing. Sorry, I have made a mistake here. This is not the same thing. This reciprocal, That means b square, let me write that down, b square by, wait, let me write the number, y little bit time it take, I can write simply b square by y square. Well, let me that. Then it's easy. V square by y square is equal to 1 by tan square theta. So, this is the second equation. Now, as per the question, it's given, prove that a square by x square minus a square upon x square minus b square upon y square is equal to 1. So, that's what we're doing. Subtracting 1 and 2, you'll get a square by x square minus b square by y square is equal to this. 1 by sin square theta by 1 minus 1 by tan square theta. So, what is tan square theta value? It is sin upon cos, isn't it? So, sin upon cos, and the 1 by tan square theta is cot square theta, and cot square theta is cos by sin. So, that's what I wrote. So, 1 by sin square theta minus cos square theta by sin square theta. I converted first, when let me show that. So, first I converted this to cot. Let's say cot. First I converted into cot square theta, and then this cot square theta value, I went and this cot square theta value, I wrote the value of cos square theta, which is cos square theta by sin square theta. So, the the bases are same, the denominators are same. So, the denominators are common, and then you get 1. I made a mistake again. Let me correct that right away. I'm really sorry for the inconvenience. Okay. So 1 minus cos square theta by sin square theta. So 1 minus cos square theta is what? Sin square theta, isn't it? So you will get, what will you get? You will get sin square theta by sin square theta, which is 1. So hence, it's proved. Okay, as we have completed the elimination of theta, let's start with allied angles, and here is our graph. So I feel the whole thing belongs to this graph only. I mean, yeah, this whole table, this table right here, this thing literally is used for this. Limit is that actually is disturbing the table. Now let's find it. Yeah, let's open the pen. Okay, so what I am wanting to tell you right now is about this, how to remember this, and why is it like this. That's the actual derivation. You know, the not going in derivation, I'll give you a slight mind of what actually that is. So, that here all ratios are positive. So let's take sin theta. Sin theta is opposite by hypotenuse. Yes, I remember that. So let's say from the origin there is one vector coming, an arrow. I mean, that makes a theta angle here, and it comes around like this. So value of sin theta is adjacent by opposite. That's what. Sorry, why am I saying that is some other value? That's not value. Sin theta value is opposite by hypotenuse. Opposite, this is opposite, and hypotenuse, this value. This by this. So here the this hypotenuse value is positive. The opposite value is also positive. So that's why all ratios are positive. Not all ratios. Sin theta value is positive. But then if again these opposite, if all the values are positive, then obviously all the line segments are positive. The line segment magnitudes are positive. Then obviously all the ratios will be positive, because it's a positive value by a positive value gives you a positive value. So all ratios are positive. Next, here in the quadrant 2, this is where the things turn. It takes a very weird turn. So now you have a vector there. Don't mind the crooked drawing. And then you have this, the opposite. And this is the angle theta. So here, this magnitude of the vector, the value of the vector, the arrow, is negative. Am I right? So hypotenuse value is negative. And then the opposite value, it is a positive. Opposite value is positive. And then hypotenuse value is positive, opposite value also positive. But then only the adjacent value is not positive. So cosec is what? Cosec is hypotenuse by opposite. And sine is what? Opposite by hypotenuse. So if both of the values are positive, then obviously sine theta and cosec theta value will be positive, isn't it? So that's why sine and cosec here are positive. But then the other values where adjacent is also used, obviously it will be negative. So that's why only sine and cosec are positive in this quadrant. This is the second quadrant. Third quadrant, tan and cot. Again, the same thing. You draw a vector for each thing. You draw a vector for each thing. You will only understand. If you draw a vector for each of them, you will only understand what it is like. Not what it's like, how the values will be like that. And then now I think you might be asking, what are these values there? Oh, that is just what when you draw a vector from that line, what will be? This could be this could mean 360 or 0 degrees. This means 90 degrees. This means 180. This is 270. That's what I meant. And this 360. Yeah, to remember the values of this, I mean, many people can remember it normally. But then for the people who are not able to handle such big information, I would suggest them to take this, what I have right here. All silver tea cups. Note that down. All silver tea cups. And I'll explain you in a minute. Yeah. So, all stands for all ratios are positive. This all stands for all ratios are positive. Silver stands for sine and cosine. T stands for tan and cot. And cup stands for cos and sec. These all are only positive. Understood? Huh? That's it. That's all you have to learn in allied angle. That's the main part you have to learn. And this is one part which everyone fears about, this table. It's actually very easy. Let me show you. So, there are some addition of angles, supplementary angles and complementary angles. I think you know that. I think I'm not sure about it. Yeah, supplementary angles are some angle x. This is a supplementary angle. It's x and this is y. This is y. This is y. Huh? So x plus y is equal to 180 degrees. Huh? So let's take that in theta value. Imagine this is theta. X was theta. So what would y value be? Y will be 180 minus theta, isn't it? Exactly what's going on here. So 90 minus theta, let me tell you how to find it out. I'll show you for the value of sine, and then you can continue with that. You can continue by filling in by how the way which I'm trying to explain you. And you have to learn here about co-ratios. One small thing, co-ratio. Sine co-ratio cos, because they are what I can explain you as they have the same basis for sine and cos. Tan and cot, they're basically the inverse. They're basically in the inverse. But then don't take inverse for everything, because if you take inverse for everything, then it'll become a whole big disaster. Huh? And then you have to remember sec and cosec. Sec and cosec cosec have the same numerator. That's why they are also a co-ratio. I mean, they're not the exact reason why they're co-ratio. I'm not sure too. But then I'm just telling, if you want to remember it, you can remember it like that, because I feel it's a bit easy. Yeah. And about the theta values. Theta, if the theta is negative, theta, when can it be negative? Look, this is 180, isn't it? Let's take this is starting vector. And if you go like this is positive theta. This is positive theta. And then when you come down like this will become negative theta. This is where the negative theta comes in. So, if I say sine negative 45, become negative sine 45. Sine of negative 45. That means this negative 45 degrees there. Like this. This is negative 45. Let me erase that out. That didn't look so. Yeah, let me erase that. If you, if you take like what I was explaining you just right now, it'll be like that. So, negative 45. Sine negative 45 is negative 1 by root. Because sine negative theta is negative sine theta. Have you understand? I don't think you might not understand. Let me just explain you again. Sine sine negative theta. Sine negative theta. So theta value is negative. This is equal to this value. Get it? This is equal to this value. And then now let's continue with this allied angles. That means the added subtracted angles. Let's continue with that. So it's very easy. So 90 minus theta. 90 minus theta. Okay, this is 90 degrees, right? As I just showed you before, this is 90 degrees, huh? This is 90 degrees. So 90 minus theta would come off like this in the quadrant 1. And in quadrant 1, all ratios are positive. So you might write that 90 minus theta is sine 90 minus theta is sine theta. But then that's a mistake again there. Because I forgot to remind you, I think. But then you have to know that 90 plus or minus theta and 270 plus or minus theta will have the co-ratios. That's why I was explaining you what a co-ratio is before. Because 90 plus or minus theta and 270 plus or minus theta will have co-ratio. Remember that is a very important point. Or you might lose marks. And then a 180 and 360 are the same ratio. And then let's say, yeah. So, and then 90 plus theta, wait, 90 plus theta is in this second quadrant. Second quadrant, sine and cosec are positive. Sine and cosec are positive. That's why the answer will come as positive cos theta. But then if you take other values, like let's take sine theta, okay? Sine theta, what value will you get? So not sine theta. Tan theta, what value will you get? Tan 90 plus theta. So tan 90 plus theta, the tan value is not positive. Tan value is not positive. So it will become negative. And then in 90 plus or minus theta, you'll get co-ratio, right? So it will become negative cot theta. That's what this board is about. You just take the value, you see which quadrant it will come in. Like let's say 360 plus theta. 360 plus theta again quadrant 1. So, and then 360 plus theta, there's no co-ratio, it's the same ratio. So that's why it'll become positive sine theta. That's it. I think you can note it down if you want it. Pause the video right here and then you can note it down. Okay. So let's go with some problem. This is a very simple problem. Cos 585. Now cos 585 can be written as what? Cos 360 plus 225 now. So cos 360 plus 225 again. We need the graph here. I'm not going to go open that. So let's just make a mini graph here. 1, 2, 3, and 4. With respect to the setting, 3 is 1, 2, 3, and 4. So 360 lies there, and the plus theta comes in the first quadrant. I mean, even the 225 doesn't come in the first quadrant. We're taking 360 plus theta. So plus 360 plus theta would come in the first quadrant. We don't know the theta value, even though we do know here, but then we're not going to apply that. So 360 plus theta will come in first quadrant. First quadrant, all ratios are positive. And 360 means there's no co-ratio. That means it will not become sine, it will cos. So it will become cos theta, which is cos 225. Cos 225 can be written as what? It can be written as 180 plus theta or 270 minus theta. This time I've taken 270 minus theta, which is 270 minus 45. 270 minus 45. So cos 270 minus 45. Here cos value will be negative because only tan and cot are positive in third quadrant. So it's negative. And then in 270 cos co-ratio will come, right, which is sine. So negative sine 45. Sine 45 is 1 by root 2, which is negative 1 by root 2. The end. Okay, so that's it I had for today. And I almost forgot, oh my lord. I had given you some questions. I am going to give you some homework questions and if I'm yes. Homework questions. Remember these homework questions. In the next class, I'll give you the solution and how to solve it. So please like, share and subscribe to my channel. And what else do you want? Like any other topic if you want to learn, please put the comment below in the comment section so I can explain you next time. Thank you, man. Bye.